Alright, so a little while ago, I was doing a little bit of reading on artificial intelligence and machine learning. And then I came across this channel called The Coding Train. I ended up following along with him in a very simple program that he used a genetic algorithm to solve for a sentence using individual letters. So after I followed along with him, it really got me thinking, how far can I take this thing? And so, from this very simple algorithm, I was thinking, what would be something absolutely ridiculous that we could do? And then it hit me. Let's just program an AI that finds transfer orbits between planets, right? That's a reasonable step. So before we get ahead of ourselves, we gotta explain the basic principles of the algorithm. So why would we even want to create an AI to solve for this thing? What happens if we just tried to brute force it? Well, with the earlier program I showed you, with just a few combinations of letters, there's 27 different characters you could have, and then depending on the length, you get this big number of combinations. And with this Rocket AI, it's quite a few more. So basically, it just mirrors evolution in the same way that slow deer don't get to reproduce as often as the fast ones because they die. Basically, we're going to do the same thing, but with rockets in space. We're going to have a population of rockets, and the ones that perform the best are going to be duplicated with slight mutations in their offspring, and then the ones that don't are just going to get copied over. All right, and so that's all well and good in theory, and then all that's left to do is just make a nice little simple simulation of the Earth and the Moon, and we're going to have one rocket orbit the Moon and try to get back to Earth using as little fuel as possible. That's the whole plan. So that's all simple enough, and honestly, how hard can it be, right? It's just a couple of little lines of code. All that's left to do now is just implement the code. 700 plus lines of code later, one mental breakdown, a lot of cups of coffee, and some I wanted to work on it, but life happens. I implemented a strategy where each rocket has a list of instructions that it follows per frame. So it goes, I'm on frame 20, I'm going to be pointing in this direction, and I'm going to have my throttle at this percentage. And it does that for 350 frames. In the space simulation, it's nothing fancy, but it basically just calculates the net forces on the rocket and then adds that to the velocity, which adds that to a position, and then you're good to go. All right, so the basic problem is that these rockets have no idea. These rockets are basically just blind. They have no intuition, no experience based on previous problems like humans do. So the problem is, how do they know when they're performing their task correctly? And so that's when we have to come up with a way to numerically evaluate how good a rocket is at doing its job. So I've come up with a solution. We're gonna have like 3 different parameters. The rockets know how much fuel they've used, they know how far their distance is to the Earth, and they have something called stable orbit good boy points. That's when they've been a very good boy. So how we're gonna evaluate their performance is we're gonna let them do their thing, and then at the end of it all, we're gonna add up the tally, and the one that has the highest score did the best. Everything else after that is gonna get copied over with slight mutations. So this way, in theory, the AI never gets worse. But I am the one that programmed it, so we're gonna see. So now all that's left to do is just assign the right multipliers to each one of those values, and hopefully we get a rocket that performs really well. So no matter what simulation you put this type of algorithm into, it's gonna optimize this reward system. So it's our job as the creators of this algorithm to push it in the right direction using these as incentives. All that's left to do now, we gotta assign multipliers we think are in the right ballpark of what we want, and then we just see how it does.
folks, that's it. And I think it turned out pretty well. If you like this kind of content, go ahead and like and subscribe, and I'll try to make some more of them. Again, thank you for watching.